Hey, let's look at acids today. The textbook really wants us to know what's going on at a molecular level, and I know you guys are up for the challenge, so let's look at this together. Okay, in the textbook, it says that an acid is a compound that releases hydrogen ions when it is dissolved in water. Let's look at just the first part of this. An acid is a compound. We'll do a little bit of review. What is a compound? So here's two atoms, and what a compound is two atoms, or rather two different types of atoms, two different types of atoms bonded together. So that's what a compound is. A molecule is two atoms together, but a compound is two different types of atoms bonded together. So here we have a hydrogen atom and a chlorine atom. And you'll notice we had talked about valence electrons before. Hydrogen here has one valence electron. And remember, valence electrons are just the ones on the very last energy level. So hydrogen has one valence electron. Let me erase that. Sorry. One valence electron. And chlorine has 1, 2, 3, 4, 5, 6, 7. So chlorine has 7 valence electrons. And so remember, instead of drawing all these energy levels, we drew with a Lewis dot diagram is what that's called. So we have hydrogen, and it has 1 electron. And then chlorine, and we would just draw the valence electron. So 1, 2, 3, 4, 5, 6, 7. And that's what they look like separated. But to create a compound, the atoms would move together. So I will move hydrogen over here. Give me a moment. I want to switch pen colors. So I know that hydrogen so it has 1 that it's contributing. All right, and so they are sharing these two. You can see here they're sharing them, and hydrogen's got a full energy level, and chlorine has a full energy level, and that's how we get hydrogen chloride. Now in the book, and sometimes instead of these 2 dots right here, they will draw a dash. And what that means is that's the bond. That's where the bond is. So you would do HL and then the H and then the dash for the bond, and then we'll do Cl. And then we're only going to draw the remaining valence electrons that are not involved in the bond. And this is what you see in the book is this dash. And that is what I'll use from now on. Okay, so it said an acid is a compound that releases hydrogen ions when it is dissolved in water. Okay, what is an ion? So an ion is an atom or group of atoms that has a charge, and this charge can be positive or negative. Just a charge of some kind. I know sometimes we think about just positive, but it can be positive or negative. Okay? Okay. So let's look at this definition we have is that sometimes many compounds separate into positively charged and negatively charged ions when dissolved in water. So you saw that those two moved apart. Now, what happened is I have hydrogen over here, but it doesn't have any electrons. It left its electron over here with chlorine. So, if you remember, you have protons are positively charged and electrons are negatively charged. But if I don't have a negative electron here, so I have 0 electrons, then that leaves me with a positive charge. So since it has a charge, this is an ion. It's a hydrogen ion. And over here with chlorine, I have 17 protons and they are positively charged, but now I have an extra electron. I have 18 electrons, so that means I have 18 electrons which have a negative charge, so that leaves me with chlorine that has a negative charge, and that is also an ion. This separation is called dissociation. So that word is in your book. If you think about dis, that helps me to remember that I'm not associating anymore. So they are breaking apart, they are separating, but hydrogen is not taking its electron with it. Okay, so an acid is a compound that releases hydrogen ions when dissolved in water. So let's look at what it looks like when it releases something. And all right, here we go. So we have an acid in water, and this acid dissociates in water. And acid, I'm going to write this so we remember it later, is a hydrogen ion donor. I didn't write that very well, but. So let's look at our diagram again for hydrochloric acid. Okay, so we have H and chlorine, 1, 2, 3, 4, 5, 6, all right, plus water, which the dot diagram would look like this, oxygen, and a hydrogen bond down here. And what happens is the hydrogen from hydrochloric acid actually gets donated to water. And over here in the product, what you're going to end up with is water having 3 hydrogen atoms instead of 2. So it's not water anymore, of course. It is hydronium. It's a hydronium ion, and then you're left with the chlorine, Cl, ion we had before. So this is the HCl plus H2O, and the product we end up with, because this hydrogen atom is being donated over, now you have H3O, that's hydronium, plus, and this is a positive ion, plus chlorine, which is the chloride ion, which is negative. So this hydrochloric acid is separating into a hydrogen, releases its hydrogen ion, and that bonds with water, and you end up with H3O. So you could look at this equation and know that it was an acid just because you saw H3O here, hydronium. All right, let's look at the first question. How do acids create hydronium ions? So we kind of just went through it. I'm going to put a pause button up here. Click pause button for a moment and try it on your own. What do you think? Okay, did you come up with anything? Let's go over it together. Here's what I have. In water, acid molecules separate, and I'm actually going to cross that out and use our new word we learned. Acid dissociates and donates positively charged hydrogen ions to bond to the negatively charged side of a water molecule, because we do know water is polar. Okay. If you have, private message me if you have any further questions about that one. All right, question 2. Describe 2 properties of acids. This you should be able to answer on your own. They're talking about physical properties of acids, taste, what does it feel like, things like that. All right, question 3. Citric acid is not a strong acid compared to sulfuric acid, and why? Okay, this is a picture from the book of hydrochloric acid in water. So there's water in here in the beaker. Okay, and this shows the dissociation of all the molecules. So the blue stands for hydrogen. So here's your positive ion. And then the green stands for the negative ion, the acid that's left. And in our case, it's the chloride. But notice this arrow right here. In a chemical equation, that arrow shows or indicates a one-way reaction. So all of the molecules here are broken apart. You don't see any that still look like this, right? That still look like the green and the blue together. They are all broken apart, and the hydrogen ion has been released, and so they're all apart. This is actually a strong acid, right? It says that right there in the book. Now, you might think of something strong being something that wouldn't break, right? Like a strong board wouldn't break. But in this case, think about maybe like if you went into a haunted house and you took like your younger cousin and they were scared and they clung to you kind of like these girls, right? Doesn't have to be younger people, right? They're sticking together because they're not as brave. That one is funny. Yep, or these guys. Right, so think about the ones that are stuck together as being weaker. So in this one, you notice in this beaker, some of the acid is still together. We only have 1, 2 hydrogen ions that got left there. Okay, so in this one, where all of it's getting broken down, this gets donated and it gets combined and makes H3O and stays. But in this case, this is an example of a weak acid, acetic acid. one of these does get donated, but these arrows here indicate that the reaction, this arrow means the reaction can happen. I'm misspelling it. Let's erase that too. The reaction is happening in both directions. In both directions. So that means that, say, some acetic acid will produce hydronium, that's H3O, but at the same time, hydronium ions are converted back to acetic acid. So not all of them stay separated. So we don't have as many hydrogen ions here, and that's why it's weaker. So a weaker acid never fully dissociates. And that's the important part. So they're over here all clumped together like our friends at the haunted house. And the strong acid is standing separated from each other. So let's look back at our question. Citric acid is not a strong acid, and why? I'm going to pause right now and see if I would like you to pause the video and see if you can come up with your own answer. Okay, pause now. Okay, what did you come up with? I'll take it a little step further. Let's see if you can complete this sentence for me. Citric acid. So citric acid is weak. Citric acid, does it partially or completely dissociate in water? While sulfuric acid, does it partially or completely dissociate? So we've said citric acid is weak and sulfuric acid is strong. So you choose which one of these. For a weak acid, citric acid, does it partially or completely dissociate? What do you think? Yeah, okay, so it partially dissociates. That's why it's weak. And sulfuric acid, since it's strong, it would, completely dissociate in water. All right, I'm okay if you write this down as you see it, and as your answers for your review question. Okay, now we're going to move on to number 4. Does the following equation represent a weak acid? Does it? And if so, how do you know? Okay, pause again. See if you can think of the answer to this one. All right, here's what I came up with. These double arrows, if you remember, we mentioned before, mean that the reaction that's going on is reversible and it's weaker. So if you see double arrows in an equation, you know that it's weaker. All right? Question number 5, acid dissociation is useful in many ways, and the question goes on. I believe you can answer that one yourself. If you look at the paragraph directly above the review questions, I think you can find your answer to that. All right, bases will be next, and that'll be the follow-up video. All right, see you then.